So now we begin the second major component of statistical inference, and that's called hypothesis testing. Now let's introduce this section with an example. Suppose that your friend proposes the following game. He's going to flip a coin. Each time the coin comes up heads, you win and he'll give you $1. But each time the coin comes up tails, he wins and you pay him $1. So now, he flips the coin 5 times with the following results. And remember, heads you win, tails he wins. Tails, 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 and tails. So you lose 5 times in a row and you pay your friend $5. Now, it turns out that the probability of flipping a fair coin 5 times in a row and getting 5 tails is 0.03125. That means that if we repeated this exercise again, flipped it 5 more times, and then 5 more times, and then 5 more times, and we repeated this 5 flips 100 times, then you'd expect to get 5 tails in a row about 3 times out of 100. So, there are 2 conclusions you can reach here. Number 1, the coin is fair, and the resulting coin flips are simply an improbable event. In other words, your friend got lucky. Or, of course, you can conclude the coin is unfair. Now, this coin flipping example sets up the basic ideas of hypothesis testing. We're going to begin with something called the null hypothesis. And in the next video, we're going to talk in more detail about exactly what that means. But for now, we'll just say that our null hypothesis in this example is going to be that the coin is fair. We denote the null hypothesis with the symbol H sub 0 or HO, sometimes called H naught. So we'll say HO, the null hypothesis, is that the coin is fair. The alternative hypothesis then would be H1, the coin is not fair. So we've got HO, the coin is fair. H1, the alternative hypothesis, the coin is not fair. The next thing we'll do is collect data. Of course, our data was 5 tails in a row. And then we look at the probability of these results, assuming the null hypothesis were true. Well, remember we said that if the null hypothesis were true, if the coin was fair, then we would only expect to get 5 tails in a row about 3 times out of 100. So our conclusion? We conclude the coin is not fair. Now, in our upcoming videos, we're going to work through this process in much more detail, but the big picture is the same. We set up a null and alternative hypothesis. We collect data. We look at the probability of our results under the assumption the null hypothesis were true. And if that probability is small, then we're going to reject the null hypothesis and conclude the alternative.